Grüezi YouTubers, here is the guy with the Swiss accent. What is a hardware hacker without a soldering iron? A softie? Because of this importance of the tool and because here and there viewers asked me about my soldering iron, I decided to do this episode. I will compare 5 different soldering irons in typical situations and at the end give my personal view about all of them. Let's start. The 5 soldering irons are: first, a 35 years old Weller Magnastat as a reference and to show the capabilities of our fathers, or, depending on your age, grandfathers. Second, my main soldering station, the Aoyue 968A+. I always have to look at the product to get the spelling right. Number 3, a cheap 907 constant temperature electric soldering iron from Banggood, 60 watt rated. Fourth, a small and cheap 60 watt Mustool MT223, also from Banggood. And 5, an innovative TS100 digital soldering iron with an STM32 microprocessor, an accelerometer and a display. This device is rated from 17 to 65 watts depending on the supply voltage. In this episode I will test several aspects. The first is the real electrical power at the beginning of the heating process. Next I will check if the chosen temperature is the real temperature. And then I will measure how long it takes till the irons are heated up. This shows us if the power comes fast to the tip. Everybody knows how annoying it is to wait for a heated soldering iron. And if it is slow, you tend to leave it on for the whole day and waste energy. At the end, I will show additional features like smoke absorber or automatic switch off. I will also give you an indication on the price of the stations. But first I will show you the different candidates. I purchased the Weller Magnastat in 1982 when I got my degree in electronics engineering. It consists of a transformer, a heating element and the magnet which interrupts the current if it reaches a certain temperature. This temperature is fixed because it's the magnet's Curie temperature. Back then, this was already a big advantage because the temperature of the tip was constant, even if the iron had a decent power of 50 watts. We do not need to talk about its quality. It speaks for itself. The only maintenance was to exchange the tip once. The price then was, similar to the Weller products now, very high. When I restarted my lab, I thought that I have to have a modern soldering iron, but did not want to spend the money for a Weller again. Partly because I was not sure if I would go on, partly because I thought that the Chinese irons have a great bang for the buck. So I bought the Aoyue 968A+. It is a combined station with soldering iron, heat gun and fumes extractor. The vacuum pump of the fumes extractor could even be used as a holder for small SMD parts, but I never use this feature, probably because I do not want to change the plumbing just for the few parts of a small PCB. The heat gun, however, is used regularly, mostly to shrink tubes, but once in a while also to solder an SMD. Especially ICs can easily be soldered or desoldered using this heat gun. Usually I use the normal soldering iron also for SMD resistors or transistors. The fume extractor is very important for me. I discovered this in the last weeks when I did use the other soldering irons for this test. Without this feature I got all the smoke into my nose. Maybe it will not kill me in these small quantities, but still it does not smell good. So I really like this feature, even if I know that the smoke is only removed and distributed into the lab through the heat gun. but still it is not directly into my nose. The quality of this station is not very good. I already had to exchange the soldering iron once because it did not work anymore. Fortunately, the replacement was dirt cheap. I also had to replace the fume filter and clean the piping because it had no vacuum anymore. The next one is the 907. I purchased this soldering iron because from time to time I have to do work in another room or at another place. In the past I took the Weller with me but found it clumsy. So I wanted a cheap and mobile alternative. This iron is not used very often, but then it's highly valued because it is very portable. The smaller Mustool MT223 is just part of this test because I wanted to give some choice for the young viewers or viewers with a low budget. This is, together with the next iron, my newest tools. Last but not least, the TS100. This is a remarkable tool because it uses newest technology to improve the comfort. I intend to replace the 907 with this tool because it is not powered by 220 volt. For this test, I use an old laptop power supply at 19 volts. Fortunately, its cable had the right plug. This is not easy. The normal 5.5 mm plugs of my drawer do not fit. This is also why I cannot test it with 12 volts. So keep in mind to purchase the right plug together with the iron. Interestingly, this iron is open source, so if you want you can write your own code. And even without writing your own code, you can influence the parameters by connecting it to your computer's USB port and change a text file with the parameters. So now you know all the different irons and we can go on to the first test. I plug each iron into the power meter and check the power it consumes. By the way, only the Weller and the Aoyue came with a stand. For the others you have to find a solution or order one together with a tool. A stand is indispensable. Now the first test, power consumption. The Weller has 57 watt, a little bit more than advertised. The Aoyue takes already 20.7 watts without switching on anything. And now it only takes about 40 watts, so the iron itself is 20 watts. The 907 takes 60 watts, exactly as advertised. The MT223 has 21 watt. Now the small TS100, and now it takes also 50 watts. So at the first test the Aoyue is completely disappointing. It should have 50 watts as advertised and it has only about 25 watts. So I do not know whether this is this new iron which I replaced, which is really bad, or if the original was already so weak. Also this small Mustool should have 60 watts as it's written here, but it has only 20. The second test is the temperature test, and because the temperature of the magnastat cannot be changed, I will reference all to this temperature. To measure the temperature, I purchased a faked Heiko FG100, which has a small temperature sensor here and shows the temperature in the display. Now here it is not so important that this is exact, we just compare. So let's check what temperature this magnastat tip should have. I hope you can see it has a 7 here on it, which means 700 degrees Fahrenheit, which is 370 degrees Celsius. So let's check first the Weller. We wait till it has reached its temperature. Now it has reached its temperature. So we get to about 162, 163 degrees maximum. The next is the Aoyue. I also choose the temperature of 360 degrees. Now we have reached the temperature, and you see here this temperature regulation is different to Weller. The Weller switch is just on and off, and the Aoyue changes also the power. So this is a little high, 380 degrees, 384 degrees. Now I adjust it. Also the Aoyue to 370 degrees. And it shows 340 degrees. The next one is the 907, and you see here we can just have between 350 and 375. So this should be about 360 degrees. Now we should have the temperature, and you see here it's 0, so it's really switched off, completely switched off. And this is a little bit disappointing. It is only 277 degrees. Now I have to adjust the temperature knob till I get this 360 or 370 degrees to have a comparable number. So I cannot reach this temperature. The maximum temperature is 321 degrees. And now I'm on full scale. The next is the Mustool. Again, the same principle. I also place it at about 360 degrees. Still heating. I thought this takes forever, and then I tested the temperature, and the temperature is pretty high. It's 500 degrees Celsius and still heating. So I doubt that the regulation works. Let's go down to the minimum. The temperature is coming down a little bit to 450 degrees, and it starts again to heat. So I assume that this regulation somehow doesn't work. It smells also not very pleasant. The last one is the TS100. We switch it on, and we have to select 360 degrees. 360 degrees and switched off, more or less. Now let's check. 326 degrees, not 360 degrees. So we have roughly 360 degrees. And it shows here the temperature of 390 degrees, so 30 degrees difference. With this test, we look how long it takes for each soldering iron to melt this very thin solder wire. Let's first check if the iron is cold. It is. Now we start. It's heating up. It's not melting yet. Now it's melting. 32 seconds. 32 seconds for the Weller. The next is the Aoyue. It's okay. Start. And it's heating up. Nothing. Now it starts. Now it's okay. 50 seconds. The next is the 907. Let's check. More or less cold. I start. And it heats up. Now 42 seconds. Next one is the Mustool. Check if it's cold. It is cold. Start and plug in. 47 watts, 34 watts. It starts to solder. 37 seconds. And now the last one. It's already plugged in, but it's not switched on. So let's check. It's cool or cold. Now I start, and it soldered already 12 seconds. This is the last test. In order to understand the heat transfer from the tip of the soldering iron to a PCB, I use a PCB with no traces. So I have a real big thermal capacity, and in the middle I have a small point of solder, and I want to heat this with all the different soldering irons. This is one of the worst cases on a PCB to have such a ground plane here. So it is hard to melt this here. The first is the weller. It's heated up, doesn't take too much energy. Let's check. 360 degrees as before. Now we just wait till it heated up again. Switched off, and now we start. Immediately it works. And of course the iron has to start again to heat up. Very fast. Now the Aoyue. Let's check temperature. 360 degrees also. Now let's start. It's switched off now, more or less. And I start. And it's also fluid, quite fast. The next one is the 907. This iron did not reach this 360 degrees. At least it's full throttle. Pedal to the metal. We get to 320 degrees. Now this has a disadvantage, definitely compared to the other. Let's try. It's also very fast. I don't think it's a big difference between this one and the others. Now the Mustool. Because we cannot trust the temperature, I have to check again. So with the minimum setting for the moment I get about 370 degrees. So let's try the test. It uses only 10 watt for the moment. Very fast fluid. No problems. But you see, it does not increase the power. So there is no regulation. Or the regulation does not work. So this is the last one, the TS100. It's roughly 365 degrees. Okay, now it's hot. And it's also fast. So people would expect sometimes, because this has a very small mass here, because it's so lightweight, that these kind of soldering irons would not work perfectly in this situation. But this one has no problems. It melted this solder very fast. So this is very astonishing for me. Now we come to the bells and whistles, and we start with the weller. The weller has really no bells and whistles, but it lasted 35 years. The next one is the Aoyue, and you see it already. It has a fume extractor here. Let's solder here, and you see the rosin core creates quite a lot of fumes. Now the fume extractor is switched on, and you see the smoke disappears immediately into this vacuum here. These two here also have no bells and whistles. Now to the bells and whistles of this small device with a microprocessor and an accelerometer. We just leave it here and wait. This is the same situation as it would be in a stand and waiting for the next job. After a few minutes, the temperature is reduced to 200 Celsius. Now what happens? If I take it, immediately it heats up. And you see how fast? you do not have to wait too long and you have your working temperature. Now, if you wait longer than 10 minutes or so, it switches off completely. The explanation for the bad behavior of this Mustool is obvious here. I took it apart and you see here the heating element has only 2 wires. And you see also the sign here, just a resistor. If you look at the normal heating element, you see that all the heating elements with temperature control have 4 different wires. 2 for the heating and 2 for the temperature sensor. So this is clearly not a temperature controlled device, even if it has some potentiometer here. Here are the results of our 3 tests, plus the bells and whistles and the prices. If we start with the old Weller, it was a very good product and it met its specifications and was worth the money. The next is the Aoyue. It has 2 red flags because of its weak iron. Its advantage is the compact design and the combination of soldering iron, fume extraction and heat gun. This is a good concept for a guy like me because I need all of them. The price is good compared to the features. The 907 is definitively a good choice for a cheap soldering iron. It does its job for $12. The red flag for the temperature is relative if you use a trick. You find the minimum reading where your solder starts to melt. From there you can add more or less based on the delicateness of your components. The melting point of your solder always stays the same. That it does not reach a high maximum temperature is not critical for lab work. The Mustool is a failure. The TS100 was a surprise for me and I used it in the last weeks for my normal lab tasks. It worked very well. Because I made big pauses between soldering, it switched off quite often and I had to restart it before soldering. But its extreme fast heat up time made this no problem. Maybe I will tweak the parameters a little. It's lightweight and its small tip made it a good choice for delicate work. And the test shows that a good temperature control together with a fast heat up time can replace thermal capacity of the tip to a certain degree. For sure, a surprise for me. For a primary soldering iron, this would be a good choice if you do not need the features of a combined station. Then the price is okay. For a mobile iron, it's probably a little bit too expensive, unless you do not have 200 volt at all places. I hope this 100th episode was useful or at least interesting for you. Because of the importance of the topic, it was longer than normal. Bye!